are classes and objects? Any answer? Anyone who would like to type it or say something? What he understands from class and objects? Yeah, it's someone says it has attributes and instances. Who has attributes and instances? Class or objects or both of them? An object. Okay, my question is now, so how do you define a class and how is a class different than an object? I understand that the technical details specifically related to Java, you understand it, but it's good to understand the basic understanding. That's very important. So again, who can give me some insight into classes and objects and what makes objects different than classes, for example? Any answer? Okay, so I don't know if this is no answer. Hopefully others can hear me, right? At least that is my assumption.
Maybe a class is a group which has variables and methods inside it.
Okay, a
One
class is,
or one or more methods or one or more variables.
Okay.
Well,
And what
an
about
object
objects?
is a specific type with a specific characteristics.
Okay. It says there's a nice, okay, there are some other answers here. Someone says an object is a part of a class, but how does it become a part? That's important to understand. One another answer which looks more interesting is we make a class to make objects. Another one is we can make an object of a class while we can't do the opposite. Okay, somewhere there, the idea here is this, a class, you can call it by different names. You can say a class is a type, or a class is a concept, a class is a template, for example. So a class is an idea, so to say. Okay, and objects are actual instances of a class. So as some of you have hinted that in your answers. So what the idea here is that the class, once you define a class, once you design a class, you're basically explaining, or you're basically so to say defining a concept, an idea, a template. And you're saying, what does that idea mean? Idea means that I'm defining a class which has a certain name. So this is one important element in a class, is that a class has a class name. Okay, class name, and it has a list of, a class has a list of attributes, and again a class has a list of methods. This is how you define a class. You give it a name, you define a list of attributes belonging to the class and a list of methods, but still this is yet just an idea. So once you define a class, you're still just defining an idea. It's not something, so to say, in a virtual world, is something no real objects are created yet. So once you create objects of a class, that's the instantiation of a class. So this is where you create the real things in the virtual world, so to say. Okay. Just give me a minute. I got some messages here. Okay, good. So is this getting clear? So we are saying class is a concept, is an idea, and objects are instances of a class. So objects are the real thing, so to say, in the virtual world. Okay. Now, how do we define a class? A class has a name, a class has a list of attributes and a list of methods. Now, what makes another way to look at it is once you create an object of a class, of course, different objects which are created from a class are from the same class, right? In a sense, they have same list of methods, and the list of methods is what defines the behavior of a class or the objects of the that class. So list of method, I'm writing down here, defines the behavior of a class, or the behavior of methods, objects of a class, defines the behavior of the objects of the class. Okay, so this is one thing. What about the attributes themselves? The attributes, the list of attributes, it defines the information which is part of the object, right? So at the class level, once you define the attributes, you just explain, you just define that any object belonging to this class will have this list of attributes. But you don't have actual values in the attributes. Once you instantiate a class, once you create an object of a class, you give specific values for those attributes. For example, if I have a class and let's say its name is student. So let's say I have a class called student and it has an attribute called name. So what happens is that if you create an object of a student, it will have a specific name. And another thing, let's say there's another attribute called ID. Another attribute called, for example, email. So this class has 3 attributes, and if you create objects of that class, it will have these 3 attributes and specific values for these 3 attributes. That defines the information, the identity of the object. Okay. So generally speaking, you will not have all the objects of the same class will share the same template. In a sense, they'll have the same methods and the same list of attributes. Means the name of the variables, the attributes will be same, but it will have some values of the attributes which will be different. In a sense, what I'm trying to say is that if you look at all the values of an object, it generally speaking, it will be not exactly same of any other 2 objects. So no 2 objects of a class will have exactly same attribute values, but will not have same attribute values. I hope this is making clear. Okay, good. So we understand. Now there are a few quick things to keep in note. A class name should start with a capital letter, right? The first letter of this name, the word should be capital. So student, we say S is capital and student, the remaining is small. This is again a guidelines and it's important from software engineering perspective. You can easily define a class which is having the first letter being not capital, and it will compile and execute, everything should be okay. But the thing is, it's not a good practice. So from software engineering perspective, we have to keep in mind that we name a class such that the first letter of the word is capital. And if you have a class which have multiple words, then each of the word will have the first letter being capital. On the contrary, the list of attributes, how you name them, you name with the first letter being small. So name, ID, email. You notice here, all of them starts with a small lowercase letter. So that's again, from software engineering perspective, this is important. And this is also important in a sense that helps us in many other things. We'll see shortly. Similarly, once we come to methods, which define the behavior, we have words like, for example, get name. We have calculate GPA and stuff like that. Okay. So you can see again the names of the method. The first letter is again a small thing, not a capital. It's not an uppercase letter. Okay. Now things to keep in mind. Generally speaking, you name a class as singular. You don't call students as a class. You call student as a class. Okay, because it's a concept. Unless the concept itself is a collection. Okay. For example, student list, you might call students. But generally speaking, a class is a concept, so it's a singular, right? So you don't call it students. Similarly, a class, generally speaking, the name of a class is a noun. So how you name a class, you give a noun, right? Like student, instructor, course, car, pen, whatever you call it, right? It's a noun. Similarly, the list of attributes are themselves nouns. Okay, but the methods are verb. It explains you a behavior, something you can do as operations. So these are basically verbs, right? Get name, calculate GPA, right? So you're speaking about some action to be taken, some behavior, right? So this is again important to keep in mind. I hope there's no question. If there's something, either write me on the chat or you can unmute and tell me if there is any question at this point. Okay, so we understand now what are classes in general speaking and what are my objects, which are instances of the classes. Okay, Now, the question to keep in mind is, why do we come up with classes? Why classes in the first place? Okay, that's a very important thing to keep in mind. Why classes? Okay, so to answer that question, we have to go a bit of programming paradigm, which is a topic we are going to come later anyways, but it's important to discuss at this point. So keep in mind, once you're doing programming, so once you're going to implement your functionality, so we spoke in software process in terms of software engineering, we do requirements, we do design, and we do implementation. So at the end of the day, most of what is there, which is going to work, execute, is my code. Now, while I'm going to implement my ideas, I'm going to implement my requirements, I can implement using a programming language. And a programming language broadly follows a programming paradigm. Okay, so we have many programming paradigms, and broadly speaking, so this is an important topic. We'll discuss this later more, but at this point of time, it's important to know some few things. So we say programming paradigm. Okay, broadly speaking, we have two different programming paradigms. One of them is called imperative, and the other is called declarative. We have declarative. Okay, most of the popular programming languages like C, Java, C++, Python, all of them belongs to imperative programming paradigm. So C, C++, Java, you have, for example, Python. These are imperative languages. There are some popular declarative languages. For example, you have SQL, structured query language. You have, for example, Scala, a famous language. So these are declarative languages, but many of them, as I said, are the popular ones, imperative. Now, once you speak about imperative languages, you again can classify them as two major ones. One of them is called procedural, and the other one is object oriented. Okay, similarly in declarative, we'll see later on, we have other paradigms under declarative called logic programming. For example, we have something called functional programming and so forth. Okay, for example, Scala is a functional programming language and Prolog is a logic programming language. But let's focus right now for the time being on imperative, because these are the most common languages and we are going to use in software development, especially in our case. For example, we are going to use Java. So in imperative language, as we said before, we have two major paradigms, procedural, object oriented. Now procedural, what does it mean? It's very important to keep in mind. Procedural paradigm is, in a sense, a problem solving. We speak about top down. Procedural is a top down programming paradigm. What's a top down programming paradigm? The idea here is this. The idea here is that you have a big problem to solve, a software to develop or a program to write, and you believe that it's a complex thing, is a big thing, and you cannot do it right away. So it's not that you can just sit down and write few lines of code and it's done. Assuming for all practical purpose, it's a big program. So what do you do in a top-down programming paradigm? You say, okay, let's look at this, and we have this idea of what we call is divide and conquer. Divide and conquer. The idea here is this, that if you have a bigger problem, this is a big problem which you're going to solve. What you do is you divide it into smaller sub-problem. You say, okay, this big problem is basically consisting of two sub-problems. Okay, and this first sub-problem is again, let's say, three sub-problems. So you keep dividing the problem into sub-problems. And this one is basically only two sub-problems, let's say. So you keep doing this. You keep dividing the problem top-down from into sub-problem, and you keep doing this until the level you see that a sub-problem is small enough that you can easily write a method, a procedure, a method basically, and that method you can write your code in that method, and that will achieve that. That will solve what you want to do. So again, I'm repeating. So the big problem in a top-down programming paradigm, in a procedure programming paradigm, for example, you look at the problem, you divide into sub-problems, you keep dividing it into sub-problems until you reach a level of sub-problem which is small enough. So you say, okay, this you can do it directly. You can solve it writing a procedure, a method, and that will take care of it. You don't have to further think about it. And again, it comes with experience, by the way. That's very important, right? So at the end, you have procedure. So what's in a procedure program, what's your final program? What's your final implementation? Your implementation is basically a set of procedures. You have procedures, methods, so to say, and you have data which moves freely among them. So data moves freely among the procedure wherever you want, right? So a procedure, a method takes in data, it processes, gives you back the result, right? So this is how you do in procedural top-down programming. And interestingly, in ICS 102, most of the programming you used to do is basically with that type of mentality. You think about problem, oh yeah, and mostly it fits a lot in mathematical problems. So you try to divide into smaller problems and solve it, and you write procedures to solve it. I hope this is clear. If you have any question, please stop me and let me know, either by typing on the chat or telling me through the voice. Please let me know. Is everything okay so far? Yes, no? Okay, very good. So I'm expecting everything is so far so good. So this is procedural, and a very good example of procedural programming is C programming language. C is an example of procedural programming language. Whereas in case of object-oriented programming language, and Java again is an example of object-oriented programming language, we say no, we don't solve our problem this way. We don't ever solve our problem top down. On the contrary, we try to solve the problem bottom up. We try to solve problem bottom up. But what does bottom up mean here? Bottom up means here this. So you say, okay, if you have a big problem, look at that big problem and try to understand that in this big problem, what are concepts involved there as classes? What concepts are involved there? And if you can identify those concepts as classes, and you can give right responsibilities for every class, and you can identify the correct list of attributes for every class, basically you are defining each class. And then you say, how you get the problem solved. You basically have objects of the class as you try to somehow mimic the real world. So you say, okay, in the real world, how we do the things, how we go about our daily life. So we have objects around us. Every one of us has objects. So a human being, a student is an object, an instructor is an object, a chair is an object, a screen is an object, a computer is an object, and so forth. Again, we can define objects and classes hierarchically as inheritance. We'll see very soon. And I guess many of you have idea what I'm speaking about. So yeah, we can define objects and classes, and we say every object of a class does what is expected from him. What's expected from him is it takes his responsibility. So it has its list of it has his behavior, which is the list of methods, and it has its identity, the attributes and its values. And if every object does its role, the whole problem is solved automatically. You don't have to solve the problem per se, thinking of a problem itself. So again, what's the problem? What's the approach to solve if you're using an object-oriented paradigm or a bottom-up approach? You're saying, okay, give me a problem. Let me look at this problem, try to identify the concepts as classes. Let me define classes here. And a class will have, as we spoke about, a class will have a name, a list of attributes, and a list of methods which define its behavior. Then I can create objects of the classes, and these objects of the classes will interact with each other, and everyone does what's supposed to do. Itself is supposed to do. Everyone takes its own responsibility, and if everyone does what it's supposed to do, the problem is solved automatically. You don't have to solve the problem again. Is this clear? It's a very important way of thinking, right? And this is also very important to understand why we use object-oriented programming language, for example, as Java. What's the whole point of doing classes? So we want to identify those concepts. Again, I'm stopping for a moment. Let me know. Is this idea clear, or you have any question on this? Yes, no, any question? Let me know.
I just want to confirm everything. So basically, in procedural, we start from the big idea, then we break it down to smaller ones.
Exactly.
While in the object-oriented, we take the small ideas and then we try to make
we still have the big problem.
Yeah,
the problem is there. How do we get the problem? We get the problem from the requirements document, right? That's our problem.
Yes.
What we want to develop. So we still look at the problem. We look at the requirements document, but looking at the requirement document, we try to identify what concepts are involved as smaller ideas, as you said, and try to identify those classes, give them proper responsibilities, properly identify their attributes, properly identify their behavior, and then create objects of them, and they interact with each other, and the job is done. So these bottom up are the classes and how they interact. So starting with the classes, you try to identify the different classes, their relationships and so forth, and then you create objects of those classes and they interact with each other.
Question.
Yes, please.
Is procedural more straightforward but hard to have like reusability, while object oriented could be a bit more time consuming than procedural, but it is more reusable? Can I
Very
say
nice
that?
insight. Yeah, you can say that to most of the what you said mostly is completely right. Very nice. So the thing is, yeah, if you do this bottom up approach, means you identify the classes and then you try to make the classes the objects of the classes they interact with each other. So it makes it more reusable and it might have a little more overhead in the beginning. It has a little more overhead, but at the end it pays off for many other reasons. I'll come to you. Also, I see a message coming here which says, what about bottom up? What is exactly bottom and what is the up? So the bottom up, the idea here is you'll identify the classes. That's the bottom level. Given a problem, you try to identify the classes. And then once you identify the classes, you identify the relationship between the classes. And once you have those, you create objects of the classes, and the objects of the classes basically interact with each other, and the problem is solved by these objects interacting with each other. So this is how you think about it. So this is how we say bottom up. Now let's try to understand. These are two valid paradigms, but why? What about object oriented? The idea here is this. There's some understanding which is very important to keep in mind. One understanding is this. You see here, what's the smallest level granularity of procedural programming? The granularity of procedural programming is a method, a procedure. A granularity of object-oriented programming is a class, right? And so we have this concept of encapsulation. Why we call encapsulation? What's encapsulation here? What encapsulation here is basically you are saying a class as a concept. Class as a concept, what does it do? It encapsulates. What does it encapsulate? Encapsulates data, the information on behavior, the methods. So these are the attributes and these are the methods. So this is what it encapsulates. So basically it's a higher level of thinking. It's more abstract, right? A higher level of abstraction. So what happens is this. You see, traditionally, procedural programming was the programming of choice. Like, for example, C. Most of the software was developed in C. Now, because it has lower level of abstraction, you have only procedures. What happens is this, something like this. So, for example, let's say that this is, again, I'm sorry. Let's say this is your complexity of the project or complexity of the problem, and this is size. Okay, so what happens is this, that object-oriented, no, the procedural, I'm sorry, it goes like this. So you have some size, it increases, but beyond a certain point, the complexity starts increasing a lot. So if you have bigger projects, bigger problems to solve, bigger software engineering projects, as the size increases, you reach a point very soon that the complexity increases so high that it's very difficult to manage. But because yes, please. I guess there was a question. Okay, I'm not sure. So, okay, let me then continue. So this is the idea here. What happens in object-oriented typically is there. Because object-oriented is a higher abstraction, right? Because a class encapsulates inside it the procedures, the methods, and the data together. The initial complexity is a bit high. But what happens is something like this. What are we saying? What we are saying is that for larger projects, the complexity is lower than procedural programming. So if you're making a bigger project, and that's the reason why what happened in 1970s and 80s and so forth, once the projects became, the software was more and more used in every discipline, every area, you have softwares to solve problems, the size of the project became bigger and bigger. And they realized that, for example, a procedure programming became too complex to manage. So they've thought, okay, what can we do to improve it? So they said, okay, let's try to see the real world, how it works. So we have ideas like objects doing things, behavior and identity. So why not come up with a class, a concept as a class, and we create objects of this class. So it's a higher level of abstraction. So initially a bit more overhead, but then it pays off in a larger project. So again, to explain it exactly, what I mean to say is, if you have a very small project to do, if you have, I'm just saying, okay, write a program which calculates factorial of a number. Maybe you don't even need object oriented. The problem is small enough that you can directly write a method and it does your job. You don't even need a class to do it per se. Just use a method, implement a method, and it does the job. But if you have a real big project, and especially if you're speaking about business softwares, big projects, then you might have a problem if you just rely on procedures. And that's why it's a better approach to go with object-oriented modeling, object-oriented programming. Yeah. So yeah, in a sense, yes. So bigger problems is more easy to manage if you're going with object-oriented concepts. Okay. I'm so sorry. Is there a question? I guess someone has his speaker on unintentionally. Can we? Okay, good. So are we fine? Shall we move forward? Good. So this is what we said. So the idea here is, again, I'm repeating. So what we do is, typically in business softwares and generally speaking, most of the softwares, we go with the object-oriented idea because it's much easier to manage, right? Now, also somebody mentioned this question of reusability. So because class is a higher level of abstraction, right? It's a very common thing as a concept. So because class is a concept, you can easily relate in other projects. So if you have a similar concept, you can reuse that same class. So in that sense, also it's good. Okay. So good. Let's go back to the thing we're discussing before. So yeah, we spoke about object-oriented paradigm, and we spoke about Java being an object-oriented programming language, right? And that's why once we try to solve problems in Java or generally an object-oriented paradigm, we take the bottom-up approach. Okay. Now the question is, we understand what's a class, what are objects. Objects are instances of a class, and we want, given a problem, so in a bottom-up object-oriented approach. So what would be our first problem now? Once we are given a problem, we have the requirements document. So let's say, how do we go about? So what would be our answer now? So our next problem now should be to come up to identify what classes I have in my project. Is this making sense? So how do we identify what classes do I have in my project, right? To understand that, we have to understand. So how to identify classes? So this is our next problem. How to identify classes? Any insight from someone? How do you identify classes? Use cases. So there's a feedback I hear, I read it. Use cases could help us think. Use cases could help. Definitely use cases can help. And actually, if you want more details, your system requirement, your use case description, right? So your problem is clearly stated in your system requirement, right? The detailed requirement. So you have to read your detailed requirements, the system requirements, and I mean mainly you have to start with your functional requirements. So you have to read your functional requirements. So this is the first pointer. So go through the functional system requirements. This is the first place to look at. Now, if I read my functional system requirements, right? How do I identify classes from there? As I said, a class is a concept, and there's a hint we have given already before. If you go there in a class diagram, we say a class is a noun. So what does this lead us to? It leads us to understand that if we read our functional system requirement, we should try to identify nouns. Is this idea clear? So we try to identify the nouns. So think about your own registration software. If you read your functional system requirements for your registration software, what are some of the nouns you're going to get? Give me some feedback, either by typing it or telling me over voice. What are some of the nouns you're going to identify?
Student.
Student, good. So let me write down some popular nouns or common nouns we can easily find out. So student, sorry. Yeah, this is one of them. What else? So okay,
just to
I
make
can see
sure,
here. Yeah, I get one of them called credit hours, which is right.
Just to,
we
are making classes right now.
No, we are just trying to identify the nouns. Some clear nouns we can find from our requirements. So I have name.
Weekly schedule.
ID. Okay, weekly schedule. So let's call it schedule for the timing. Schedule. What else? Do we have instructor?
Admin.
Admin.
Basically every actor. So
Contact.
Faculty development.
Contact. Contact number. Do you agree? Email ID. Address. Good. What else do you think? Again, there will be many, but just as a quick list. We have course name. We have credit hours. We have major, right? Section, do you agree? So these are some examples of nouns. CRN and so forth. Good. Now what will we do? If you identify from our requirements document the nouns may be of different categories. Some of the nouns, again, let me write it here. So some of the nouns are going to be classes. Some of the nouns are going to be classes. Some of the nouns are going to be attributes of classes. But there can be other nouns as well. For example, some of the nouns are speaking about actors, human users, right? Some of them could be physical objects, card, I don't know, some other things, physical objects, it could be. But the most common things would be, you'll find classes, attributes of classes, and actors and users. Good. So now, how do we identify that a given noun is a class or an attribute of a class? For example, let's focus for the timing on these two. How do we identify that a given noun is a class or an attribute of a class? So the idea here is this, that let's look at it. So let's look at one by one. Let's look at student. Now, student, if you think about this concept as a student, now what do you think about student from your requirements document? Student would be one thing, or there you need further information to explain what is a student in your system. Is student by itself complete, or student is a concept that needs further explanation? For example, you might say, oh, a student has a name, a student has a major, a student has a contact number, student has an address, student has an email ID. So you see that some nouns are defined in turn by other nouns. So if a concept needs other concepts to define that particular concept, is a good indication this is a class. So based on this, what do you think? Student is a class or a attribute? It's a class. Very good. Yeah, so we understand class. Now let's think about credit hours. Should it be a class or an attribute? Think about credit hour. Is it a concept you need other concepts to define it? Or you can say, oh yeah, what's a credit hour? Credit hour is a number which is integer between 1, 2, or 3. So maybe a basic type like integer in your programming language can define it. So yeah, maybe you think a credit hour
attribute
is an attribute. Similarly, name. So we already spoke about it. So let's assume name is a simple thing. So we think about this being some sort of unsigned int. And a name could be a string. So you say, okay, student, a name can belong to, for example, here is in the context of a student. Of course, a faculty, an instructor can also have a name. So there can be two classes have same attribute. Similarly, ID. What do you think about ID? ID is again going to be an attribute. You may think, okay, based on the
Attribute.
problem, based on our problem, we said an ID is a 10 digit or a 9 digit thing. So maybe it's a 9 digit unsigned int, right? 9 digit unsigned int, nothing else. So it's again an attribute, and maybe it's the attribute of the class student and so forth. So the basic idea is going to be this. As a concept, if it is defined by other concepts, so it needs other concepts to be, you need other concepts to define that concept, then that concept is going to be a class. Otherwise, it's going to be an attribute, a basic attribute of a class. But there are some interesting things we have to also keep in mind. Think about schedule. What is schedule? A student has a schedule. You agree? For example, a student has a schedule. So in that sense, a schedule is an attribute of student. Good.
Class.
But then, yeah, then what is a schedule? What's a schedule? Is it a concept? It can be defined by primitive types like integer, string, character, double, or no, schedule is a concept. It needs further explanation. Maybe it needs further explanation. Because schedule, how you come up with a schedule? The concept of schedule is a collection of, is based on your sections you're taking and the timings of those sections. So it needs further explanation. Are you with me?
Yes.
Good. So in that case, yes, schedule, although it might be an attribute of the student, but itself can be a class. Similarly, instructor. As with the case of student, we can easily find that it looks like to be a class. What about admin? Most likely it's a class. What about contact number? So we will, if we read our requirements document, we might find that this contact number, this noun is appearing sometimes once we are discussing a student. Sometimes it appears once we are discussing an instructor. So we understand that this can be an attribute. And what's a contract number? It's basically a sequence of digits. A sequence of digits. For example, for simplicity. So we understand this contact number can be an attribute and it can belong to an instructor class, student class, maybe other classes, and so forth. So do you get this basic idea? How we identify that a class, there's a class or an attribute of a class? Good. Now a quiz for you. Think about major. Now a major, is it an attribute or is it a class? And this is very important. This question, if we can discuss this question well, we'll understand what exactly I'm trying to explain to you. So a major, is it a class or as an attribute? What do you think? Either type it on the chat or let me know by voice. I'm speaking about major.
I think it's an attribute.
Okay, so I can already see.
No.
Some people are saying attribute. Yeah, so I can see some people are going to say as class and some people are going to say attribute. And there's a nice answer. It depends on what we treat in our software. Exactly. This is a very nice one. And depends on the way we see it. These are right answer. So the thing is here, you have to go back to your requirements document and you have to see how is major, this word major being discussed in your requirements document. Assuming the only way you are discussing a major is that a student has a major. Our course depends on a major, and that's it. That's how you discuss major everywhere in your course, in your software. Then most likely what's going to be a major? Is it a class or attribute? In this scenario, assuming the only way you see in your requirements document is a major, you say a class, a course has a major or a student belongs to a major. Most likely in that sense, you will define major to be, you say, okay, there's no more information about this requirement. Most likely I'm going to define it, for example, as a string. And that's going to be an attribute. Okay. But then you may have some requirements. It speaks about creating majors. Again, I'm not saying that every one of you will have, but assuming that there's a software where there's a requirement and there's a use case called adding new majors in your software. And if you go to the details, it says something like that. A major has a name and it has a 3-digit code. SWE ICS, and a major belongs to a department. So now what we understand, this thing has a concept and it needs other things, other ideas to explain it. So a major is explained by a name, a 3-digit code, and it belongs to a department. So naturally, if that is going to be the case, a major is going to be a class. And that's why what this is a very important thing, and maybe we'll stop in this discussion. The very important thing is, just by looking at the noun itself, we cannot identify that it's going to be a class or a attribute. In some projects, the same noun can be attribute, whereas other projects, the same noun can be a class. You can't just decide like that. It depends on the software you're developing. So you're going to go through the software, you're going to understand the details of that software, the requirement, and you see how that particular concept is treated in your project. Okay, and based on that, similarly, think about this. Okay, think about address. Now, I might see in my project address is always just mentioned as one thing, address, and I say, okay, I can put a string, and that will basically explain my address. It's a string. It's a collection of words, right? But then I might find somewhere as a discussion, oh yeah, you know what? The address has to be, you have to have a house number, you have to have a street number, you have to have a pin code, and the address might include a city and a state. And all of that has to be there as a part of address. Then we understand that address becomes a class. But if it's not discussed in that context, an address could be just a primitive idea, just one idea called address, we can, at this level of design, we can safely identify address being a attribute of a class. There's another thing is, once we do this exercise, once we identify all our classes, later on, once we go to detailed design, further detailed design, the concepts which are coming as basic attributes on my attributes from my requirements might further be identified to be classes. That's another thing. We can model it as a class, but at least the thing which we are doing right now is, given the nouns from my requirements document, we do this exercise, we try to identify the classes and try to identify the class attributes based on the thing we just discussed.